There we go. Well, hey there, everyone out there. It is 2 hours UTC, and it's time again for Astronomy Daily Live. Yeah, I'm back. Had to work a little bit late last night. Didn't want to rush. I hate rushing. I will avoid it like the plague. So it's just a lot easier just to sort of can 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 things a little bit and pick the ball up and run with it the next day. So here we are, and here we are up there too. Hello there. So on the panel, I see Bobby. Hey, what's going on?
Nothing much. Saw that cat just jumped over that PA and stuff.
Yeah, she's on the move. She's on the move. Here she comes.
Uh-oh, kitty cam.
Lock the screen. I cannot see. Keep moving there. Keep moving. Keep moving. Keep moving. All right, cool. And also, Tom is on the panel again. Hey, Tom.
Hey, everybody. How y'all doing? And about your work last night, that's one of those things where, you might as well do it right if you're going to do it.
Yeah. I'm on such an incredibly flexible schedule that the thing is to get the job done, right? And no matter how long it takes or whatever, just do it. Do it well. So yeah, sometimes those things.
That's why when I was working at Walmart, man, and we had a management that didn't give a frack about us.
Huh.
But now, if I was able to go back to Walmart right now, they will guide you in every step of the way.
Oh, that's cool. That's cool. So yeah, sometimes I get going on things, and I'm going and going and going and going, and I look up, and it's sort of like a blink of an eye, and I look up, and it's like, oh wow, it's late. So yeah, those kinds of things happen from time to time. All that really means is that I'm just having a great time. So such that time just isn't there at all. Just bam. So yeah, those kinds of things are going to happen from time to time. No worries at all, because science of astronomy persists for sure. So
Matata, what a wonderful phrase.
What's that?
You ever seen Lion King?
Hakuna Matata?
Yeah.
Yeah.
It means no worries.
Yep.
For the rest of your days. It's so problem-free. Philosophy. Hakuna Matata.
Yep. Yeah.
I think I butchered that, but yeah.
I will tell you a story about Hakuna Matata. So, and this is going way, way, way back. So this is the fall of 1987. Okay, and I want to say maybe August or September. So end of summer, first part of fall. I forget exactly. I was a freshman student at the University of Arizona in, of course, the astronomy department, and I don't remember exactly how I got it, but I got it was just a volunteer job at the planetarium telescope. So I would operate the telescope. They after the planetarium shows, they would invite people, to come upstairs and look at some things through a telescope, right? And it was a 16-inch. It was a 16-inch. It was a. I think it. I'm pretty sure it was. It was a German equatorial mount. It was some. I think it was a Schmidt-Cass. Pretty sure that it was a Schmidt-Cass, but it was big, right? It was really, really big, 16-inch. It's pretty large. And so I've been doing this for at least a couple of months, a few months, going up. I want to say I was doing it maybe 2 or 3 nights a week or so. And one night, this guy came up. This kind of like a bear, right? Just sort of this big dude, big huge beard, big afro, right? Just just this big dude, right? And he storms up the stairs, right? I mean, everybody's waiting in line, right? Everybody's waiting in line. I'm sort of, on their right side, right? So there's an aisle, to go down, right? Well, he's storming up that aisle, and he comes up, and he tells me that he built this telescope, and I look at him, and it's like, yes, sir, just sort of wait in line, right? And he's insistent and everything else. I forget exactly. But so fast forward maybe 3 years or so, and I have a mirror, a telescope mirror, the first telescope that I built when I was 12 or 13, and the mirror it wasn't in the best of shape. Its figure had never been really great, and I'd always wondered about being able to fix it, right? But I didn't know anybody, right? I have no idea at all. But this one day I hear about this master optician who has his own optic making shop, right? He makes telescope mirrors and lenses and all of that, and he's just down the road. He's got sort of a lab thing going on, and so I visit this guy, and it turns out that's the same guy that interrupted me at the telescope at the planetarium. It's the same guy. His name was Bob Goff. And really an amazing guy. In every sense of the word, he was just pretty amazing. I mean, really smart. Really, quick-witted, and just incredibly smart, right? I mean, really knew what he was doing incredibly well. And he took my mirror and, did his magic, and actually got it to a 20th of a wave in terms of smoothness, which is pretty much about as perfect as you can get. Anything a 20th of a wave or smaller is incredibly smooth, very smooth. So yeah, he polished my mirror to a 20th wave, which I just right away, I noticed the difference. Right? I mean, it was almost like I could see maybe twice as many stars. It was that much. Um, so yeah, you know, I had used that telescope mirror for, wow, let's see, 15, probably 7 or 8 years at that point. Is that about right? Yeah, maybe a little longer than that, maybe like 10 years or so. Um, so yeah, once it was smoothed out a little bit more, wow, it really went well. But he and his wife had two cars. He had his, she had hers. His license plate read Hakuna, and her license plate read Matata. And so I always thought that that was very, very cool. And that's exactly, that is precisely the kind of thing that Bob would think of and do, because that was the amazing thing about Bob, was that when he decided to do something, he just did it, right? He was like a bulldozer, just bam. So I'm very, very, very good at what he does, very, very good. So yeah, he's been gone for, it's got to be close to 20 years now. That'd be pretty close, pretty close. So yeah, I actually worked in his shop for off and on for a couple of years at least. You know, polishing mirrors and grinding mirrors and making secondary mirrors. You know, the flat secondary mirrors, big huge mirrors. I think he made a 30-inch in there once while I was there. I think that was the biggest one he made in there. So yeah, that was pretty exciting. But yeah, you know, a lot of 6-inch, a lot of 8-inch. Yeah, yep. And don't remember who was buying those. I want to say it was Mead, but I don't remember exactly. So anyway, I just remember the license plates because um, that was definitely Bob. Don't worry, be happy, and that was his thing. And boy, I sure try to be that way, but well, he's he set the high bar in terms of that phrase. So cheers. I am absolutely parched, so I'm glad I have a full glass of this hydrogen hydroxide here, HOH, the acid and base at the same time. It's like you know, two sides of a coin. So very, very cool. Oh, my screen just went black.
You should get something called caffeine, and you should be fine.
Caffeine and I should be fine. Yeah.
Yeah, there's
Well,
screensaver inhibiting app called caffeine.
oh, okay. Because it's like, yeah, this is empty, so there's nothing there. Cheers.
And check the chat as well.
Chat activity. Chat activity in the chat. Ata, hi. So are you back? I think you should probably be back.
I agree with that.
Yeah. Patrick. Tom is also in the chat. Uncle Bill. Yeah.
So what is up, Uncle Bill Duran, Patrick, and Alta? Oh, she is back.
Yep, I am back now. Used to visit a lot of ATM sites. Oh yeah, amateur telescope making sites. Oh, did Bob maybe ever have an old? Um, his company was called. It was called Astronomical. I'm not going to remember the word. It begins with an X. The acronym for his company was AXE, AXE, and there was, because I maintained it, an axe.com website. So yeah, if there was an axe.com website, then we must. He probably wasn't gone 20 years ago, maybe 15 years ago. Yeah. So yeah, look for axe.com, and what I'm going to do is I'm going to try to find what that word is, because that phrase was also very, very much kind of phrase. Comical. No, it's not coming up. Well, it's astronomical Xeno something enterprises. So that was Axe. So yeah, see if you can find anything there. I'm just doing a Google search here, and nothing is coming up. So, but I guess I didn't try Axe.com. No, it's different now anyway. Totally different. Well. Well. So, all right. Well, cool. Let's see. Am I caught up in the chat? So, yeah. Well, Bob was very well known. I mean, he worked at Kid Peak as well. He got into heavy into mirror making after he left Kid Peak. Okay, yeah, good question there, Atta. In fact, I was going to share with you taking a look at that paper that sort of shows all the analysis and everything else. Yeah, I think they're just talking about mass, right? And the paper says that this object is something like 3.2 times the mass of the Earth. So, therefore, they're calling it a super Earth. But what else it has in common? Probably not much. And we can actually get into the paper here if you want, because that's sort of where I was going to go anyway. So let's dive in. Looks like she's on my shoulder there. Share.
Our perspective it is.
Yeah. Okay, so here's the paper. Just came out today on archive.org. It was actually the last article. Oh, I'm sorry, no. It was the last article from yesterday's list. I haven't actually looked at today's list because I found this. It's like, well, that's very cool. I'm going to hide that. So lots of authors, holy moly. Right? I mean, gee whiz. This is a pretty major collaboration. It's I don't know how all of these people contribute and it all sort of comes together, right? I mean, I would think having this many authors, it would take a quite a long time to write a paper. I don't know. Yeah. But wow, that's a lot of that's a lot of authors. I mean, that's like 2 pages just for all the author information. Wow. Pretty amazing. All right, so at a distance of 1.8 parsecs, there's a 1 there. What's that? Oh, I don't know. We're going to have to look that up, I guess. Barnard star is a red dwarf with the largest apparent motion of any known stellar object. Closest single star to the sun. Okay. It's amongst the least magnetically active red dwarfs known. Okay. So, combination of numerous measurements from high precision radio velocity instruments reveals the presence of a low amplitude but significant periodic signal at 233 days. Okay, so let's see. Independent photometric and spectroscopic monitoring, as well as the analysis of instrumental systematic effects, show that the signal is best explained as arising from a planetary companion. The candidate planet around Barnard star is a cold super-Earth with a minimum mass of 3.2 Earth masses orbiting near its snow line. So I don't know what the snow line is, at what distance that actually is physically, but it sounds like it's outside of the so-called habitable zone. Maybe on the edge of a habitable zone. I mean, you know, the snow line, that sort of implies that it's cold. Well, living things can live in cold environments. So, okay. Let's see. Let's see, the combination of all radio velocity data sets spanning 20 years additionally reveals a long-term modulation that could arise from a magnetic activity cycle or from a more distant planetary object. Cool. Pretty cool. So, pretty nice. They've
so Uncle Bill Thurin, I always assumed that super Earths were herbs only because they were rocky, not just gas giants. And I don't know how they're agreeing that they're calling it non-gaseous planet as an Earth.
That's a reasonable thing. Yeah, I guess the only thing that I would add to that is that Earth is sort of the combination of the two, right? It's a rocky planet with an atmosphere. So to call this object an Earth, to me, sort of implies a rocky object with an atmosphere. And I don't know if you can say anything about an atmosphere yet.
Now, our super Earths is like Jupiter, but it's also a terrestrial planet, not a gas giant.
I mean, I think super Earths, right, can pretty much be any times the mass of the Earth. The only thing would be, like I said, is that it needs to be rocky with an atmosphere. I think that's what makes it an Earth. At least in my book, it does. I don't know if there may be an actual definition. You know, if we go to like the International Astronomical Union, they may have a formal definition of what a super Earth is. And you know, let's why don't we look?
Why not?
If we can find out.
Well, what I saw quickly was it just has to be Earth mass or greater, and they have to believe that it's rocky. Didn't see anything about atmosphere, but still looking.
Now, how they can actually determine that that's a super Earth if they mention it's a rocky terrain, but it doesn't have an atmosphere?
Yeah, the only reason why they can call it a super Earth is because they can watch its orbit, right? They can watch its orbit. They can get a good orbit, and from that orbit, they can calculate a mass. So, and they're calculating what they say, 3.2 Earth masses. So yeah, that's pretty straightforward.
Yeah.
Okay. Well,
can you post that same link on the Discord so it'll be quicker for me, because I'm monitoring the chat on my phone and I don't know how to leave it out of it.
What link?
It's in the chat.
Oh, link in the chat. There's a link in the chat. Astronomy.net. There he is. Yeah.
Okay. It's talking about the amateur telescope making, the one that you was talking about.
Yeah. Yeah.
Oh, it's about Bob Goff.
Bob Goff. Yeah. Yeah. Gee, I wish there was a picture, but there it is. Astronomically xenogenic. So do you know what xenogenic means? I don't remember. Let's find out.
It's been posted in 2001.
If this live stream is going totally tangent here, because we want to find out what xenogenic means, because I don't remember.
It's a medical definition.
Yeah, it's being derived from something else. So yeah, derived from, originating in, or being a member of another species. I think that's how I'm going to read that. Let's get the actual. Or being a member of another species. So yeah. Wait. This is not spelled correctly. Xenogenic. Oh, that's not coming up.
Should we do
all right. Well, I think it's going.
Paste?
Yeah, I think it's going to remain a mystery. So yeah, he was pretty young too, 59. That's young, but he had a like a massive heart attack. I think in his 30s, that like completely wiped out most of his heart. So for the rest of his life, he moved very, very slowly. Couldn't be really physically active, because he just couldn't pump enough oxygen through his body to keep himself going. So that's what got him in the end. So anyway, yeah, there's a little article there about Bob. That's cool. That's cool. Thanks, Uncle Bill. Yeah, well, you know, David Levy knew Bob Goff very, very well. So, yeah. In fact, I think David Levy was one of the speakers at Bob's eulogy, which was attended by, gee whiz, I don't know how many hundreds, maybe over 1,000. I don't remember. It was packed. Yeah, he was an amazing guy, very amazing guy. All right, let's get back to this. I don't think that there is going to be a definition of a super Earth. I just don't think it's going to happen.
Now, do you think
Nope.
they could have dismissed it, or what else they could be doing about it?
Oh, I don't know. Yeah, I don't think that they have enough information to necessarily call it a super Earth. So, because as I said, for me, that sort of implies a lot of things. So that I don't think that they can observe, right? They know about how big it is, right? And they know about how far away a star it is. With that kind of information, they know about what its temperature is. In fact, in the paper, they have all their tables and charts and everything at the end of the paper, which, yeah, I'm not a big fan of that. But here we go. So here is some information on Barnard star itself, right? So it's pretty cool, relatively speaking, right? I mean, I think the temperature of our sun's photosphere is about 6,000 Kelvin. Is that right? Maybe 5,500, 5,000. I'm not sure. Somewhere around there. So this is a little bit cooler, quite a bit smaller, right? I mean, it's like less than a fifth of the mass of the sun, and about, less than a fifth of the radius too.
Okay. Assuming that this information is new, how long does it take for that organization will say, hey, we can call it a super Earth?
Yeah, I don't, based on the information that they present here, at least in my book, we don't know if it's a super Earth or not. I mean, it has a certain mass and is a certain distance away from its star. And I think that's all we know at this point. I don't think we have any kind of composition or anything else.
So what was the possibility of that they could have just dismissed it instead of approving it?
Oh yeah, no, I think that this paper shows that there is definitely something there. But that's about it. The analysis is actually pretty statistical. They really well, they don't exactly play with the numbers, but they run the data through these really complicated um, calculations of probability and all of that. And, you know, this is what they're basing their conclusions on. And I'm just sort of, well, it's an interesting thing, and it seems to work, but it's really complicated. So, yeah, I don't know. Here's some periodograms. Go ahead, Tom.
I was just going to say, I've been poking around a few websites, and I don't think there's really any standard for what a super Earth is. I even saw Universe Today had a definition that just said, if it's Earth mass or greater, but less than the ice giants, less than Neptune, Uranus, then people can call it a super Earth. So,
okay.
Probably one of those things that they've got on their list to do.
Is saying that they calling something in Earth is more of an attention getter than anything else.
Yeah, I would think that too, and it gets the public, you know, people who aren't into the scientific statistics that Cosmic is talking about, gets those people a little idea of what they're talking about without having to know all the details.
Yeah. I just, you know, I guess that's, you know, I think the term Earth is just a, you know, it's sort of a loaded word, right? It comes with a lot of baggage, right? Like everything we know, right? So yeah, it's sort of a stretch as far as I'm concerned to call anything an Earth until at least you have an atmosphere, at least. So, but yeah. I mean, it's sort of a really, really poor simplification of something that is obviously much more complicated. So, you know, to call it an Earth, you're exactly right. You know, that is sort of a simple term, you know, that most people, you know, can sort of understand, but it's just, you know, that word, you know, makes certain implications, right? That it has an atmosphere and maybe, you know, who knows what else. Where, you know, the fact of the matter is that we don't know anything about it at all, except how big it is.
So let's try to find the proof. Where's the atmosphere and where is that super Earth?
Yeah. Well, that is coming, right? I mean, what these guys and gals say in the end, right, is that we got to keep looking. I'm pretty sure they say that. Let's go back here. I'm gonna. These are all the acknowledgments. Here's all the references, and you know, I haven't said this recently. Every single scientific paper has all these references, right? Well, this is not only a dive into a particular topic, but it's also a dive into history, right? You're looking back in time to see, you know, what was discussed and all of that, and then that paper, right? Like this one, right? This paper will have a list of references at the end, and you can go even, you know, back in time and back and back and back and back and back. So, you know, if you're into the history of astronomy, you can basically pick up any paper you want, and you'll find an amazing story, right? Totally amazing on every single one of these topics. So yeah, it's just a great way, you know, to learn how we figured all these things out. It's all mapped in in these references. So very, very cool. So let's go back to here. Yeah. So here it is, right? The long-term, intensive monitoring of Barnard star and the precision of the measurements, gathering data from all precise high-resolution spectrometers in operation, pushes the limits of the radio velocity technique, which is what they used. They actually measured the um, the Doppler shift. Yeah, the Doppler shift observed by the wobble caused by this planet of Barnard star. Does that make sense? So we looked at the spectrum of Barnard star over, periods of time, right? I think they were saying something like 20 years, right? We looked at the spectra, and all the spectral lines would over time move in some periodic way, and what that means is that relative to us, Barnard star is moving away from us and then towards us, and then away and towards, and away and towards, and away and towards, very, very, very slightly, right? But we can measure.
There's a possibility that it could be moving around like the way our Earth is doing it, right?
Yeah. Well, yeah. I mean, that's the whole point. Is that they've taken the data and they have found some resonances, right? They can look at the data in sort of a different way, and they can find certain frequencies that seem to resonate. All right, so I don't think I'm going to get into this too much, but all these peaks here are certain resonances. Now these are talking about model and no model. I'm not exactly sure, but nevertheless, they are showing resonances.
So if that planet they're talking about has gotten everything, can we actually prove that it is like an Earth or something?
We're going to have to collect more data. That's sort of the bottom line on that. Now, this is pretty astounding.
Will our current set of telescopes will have known about this, or we're going to wait until a new set comes around?
No, this kind of scientific reporting, right? Which is basically what this is. This is going to set a lot of people on fire, right? They're going to go look at this thing, and they're going to look hard, right? And they may be able, to get a spectrum. Who knows? I mean, even if it's not very good, right? They'll get something, and that'll be very cool, right? So, yeah, I don't know what the possibilities are in terms of imaging, actually getting a picture of it. Yeah, that's a lot harder. But, now that we are pretty convinced, pretty sure that there is something there, at least one thing there, we can take a good hard look. All right, I need to do some door opening duty, so I will be right back. Hold on.
Oh Lord.
So I find this this top plot very astonishing. And the reason why I find it astonishing is I look at the units associated with the radial velocity. These folks are measuring velocities in meters per second, right? Not like kilometers per second or, you know, whatever, right? This is meters per second. And this amplitude, that's not much more than 1. So that's pretty astonishing, right? Now here's the actual data, right? So they've done a fit, right? They've tried to fit this data to some kind of a sinusoidal curve, right? And this was probably the best fit, right? That you reduced all those errors to a very, very small amount. So, you know, it's hard to do it, but if you can, try to ignore that black line and just look at the data itself. That's pretty hard, right? But I think it's pretty apparent that these data points up here are definitely higher than these data points down here, right? So it's kind of hard to see that with this black line right through there. And, you know, I mean, I understand why they do it, but that's pretty noisy data, right? That's pretty uncertain. There's definitely something there, though, right? For sure, right? Because this is definitely looks a little bit higher than this over here. But, you know, then there's these data points here, right, which are higher than everything else. So, yeah, it's hard. You know, this is hard stuff. And so, you know, still, they're being, you know, precise to 6 meters per second, which is pretty astonishing, right? I mean, 6 meters per second. That's sort of a, isn't that sort of a run? Isn't that about how fast we can run? Is that right? I'm not sure. It's not very fast. So that's pretty astonishing that we can make those kinds of measurements. Wow, pretty good.
Yeah, I would put that at a fast-paced walk or a slow run, 6 meters per second.
Yeah, yeah. So that's not bad. It's not bad, and that's. Go ahead.
I was just gonna say, so we could probably keep up with it if we wanted to.
Yeah, yeah. You know, I mean, at least radially. Yeah, cool. So yeah, you know, these are also some fits to some of the other data, and they're finding other maybe periodicities in there. It's hard. Look at that, you know. And yeah, it's really, really hard. And you see how the radial velocity here is not only moving in a sinusoidal pattern, but it also has this larger shape to it also. So what is going on there, right? And then this one is slightly increasing. You see that? So, yeah. But, you know, like I say, you know, try to ignore that black line and look at the actual data. And it's like, oh, wow, that's really, really hard I mean, that's probably a best fit, right? I mean, but it's not very good. I don't think that. Yeah, I don't think that works. I don't know. It's pretty sparse. You know, this is pretty sparse too. So it's kind of hard to. I don't know. You know, they think they've got it.
So if they can avoid that sinusoidal, what's the possibility that they might be able to find something about it?
Well, these black lines are just the best fit, right? So they've created some kind of model, right? Input a few parameters and come up with this that best fits this actual data. And again,
so the sinusoidal is something like they have the less chance, and something higher has more chances. Is that what I'm getting from?
No. This is just the measurement of radial velocity. So that's how the star is moving relative to us. So yeah, that's that. So I'm just saying, you know, this data is, I don't know. I mean, it's pretty noisy, but maybe I'm complaining, right? You know, because being able to measure with a precision of 6 meters per second, that's pretty good, right? So maybe this is as good as it gets. You know, I don't know.
Like I said, I ain't gonna argue about it.
Nah, I just like to, you know, try to analyze these a little bit, and you know, they're trying to figure this out, right? So they're trying to explain things. They're trying to, you know, do all this. I understand, right? So they're trying things, and so this is their try, and this is their story, and it's great. I think, you know, I mean, it definitely looks like there is something there, for sure, and that's cool, right? Because now we will be motivated, you know, to take a look a little harder, right? You know, than what we might otherwise, and that's great. I think that, you know, we're going to find planets everywhere. I'm, you know, like I say about lots of other things, I'm not surprised at all. You know, I mean, what would have surprised me is not finding anything. That would have been weird, right? But the fact that we're finding, you know, planets around like every star we look at, yeah, yeah, that's probably how that works. Yeah, so cool. Let me, I'm going to check the chat here. Okay, good. Good. So, all right. So, yeah, I think this is some interesting work. They, you know, they're relying on stats quite a bit. Do they, I don't know if I, yeah, here's some more periodogram. Here's the 233-day peak right here, and I'm not exactly sure what these parameters mean, but I definitely understand, you know, what the frequency is. So, yeah. So there's our. Oh, in fact, here it is. Yeah, 233 days is right about there. So it's kind of interesting. I'm not quite sure why it's not showing up in these, but yeah, I'm not gonna dive into this too deep. Here's some more statistical analysis. The so-called power spectral density of a stacked periodogram. So it's like, oh, really? Okay. So there's some pretty weird math going on here, but apparently these plots are showing how, I guess, how confident they are in their measurement. And I guess over time, the confidence gets higher and higher. That's what this top thing is. So yeah, this is way over my head, way over. So, you know, they're declaring that they've found a planet based on some pretty funky data and statistics. So I think there's probably something there for sure. But yeah, I think that's kind of a leap to be absolutely sure. And I don't know if they say if they're absolutely sure or not, but they seem to be pretty sure. More. Okay, so there are changes in radial velocity. Okay. Yeah. Pretty interesting paper, though. For sure. You know, even just a little bit of a skim, you know, that I did. Pretty cool. Pretty cool. Yeah, this is just all, I think this is all stats. This is all just models. Not even going to try. Oh, that's the end of it. So cool. This, you know, finding a planet going around a star that is the second closest star to us, or third or fourth, whatever it is. That's pretty nice. That's pretty cool. Hey, you know, I can ask the chat. I can ask the panelists here. Are we saying that we've seen actually seen any signs of planets around any of the Alpha Centauri, Proxima Centauri? Has that been confirmed or denied?
I thought there were reports about some planets in Centauri. Yeah.
Okay. I was trying to. Oh, my thing stopped here. Hold on.
I also heard about the Mars opportunity rover may be resurrected, but we got Big the Dipper.
Yeah, I saw that, and yeah, there was some kind of signal that was at the right frequency, and at least at first they were thinking that, you know, it was the right kind of data rate and all that, but maybe about, I don't know, what, half an hour after that, maybe it was an hour, heard another thing saying that no, it definitely wasn't. So I think I went on a little bit of a rant about that a couple of months ago or so, about I'm not quite sure why everybody seems to care so much about this rover. It still seems a little weird, maybe a little creepy, because I mean it did an excellent job, astonishing, right? Absolutely astonishing job, five.
I don't have any confirmable, as Uncle Bill Duran said about those Centauri exoplanets. He haven't heard anything about it in months.
Okay. Yeah, I don't remember ever hearing anything about any exoplanets being around either Proxima or Alpha or Beta. Right? Is there a Beta Centauri? Man, I'm really bad about that. If it's not in my sky, I don't know anything about it at all. That's terrible. Is it Alpha Centauri? Beta Centauri?
Well, I think there's three that we know about, right? Alpha, Beta, and Proxima.
Yeah. Okay.
And I did see an article about a planet found around Proxima. I didn't see many details of it, but there was a thing in Scientific American.
Oh wow. Interesting. I wonder. I'm going to do a quick look over on Archive.
Let me see when this was. What date this was? This is from 2016. The New World has a minimum mass 30% larger than Earth.
Wikipedia still lists Proxima Centauri B and Alpha Centauri BB.
So I'm seeing a paper from 2018 that refers to a Proxima B. So Proxima B, here it is in the abstract itself. Here, I'll share my screen here. Dun, 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 dun. Got to play the share the screen music. Dun, 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 dun. Hide that.
Yeah, I think we're talking about the same thing.
So this is saying that Proxima B is a terrestrial exoplanet orbiting the habitable zone of our closest star, Proxima Centauri. Okay. I wasn't sure. But that pretty much confirms it for me.
Yeah, it looks like they found it a couple years ago, so it probably hasn't been in the news lately.
Cool. Okay. Man, how did I miss that? Man, I'm just getting bad. I'm getting bad and old. That's all. Might as well hang it up now. All right. Well, cool. Let's see. Well, it is 3:03 UTC. Giving it a good hour here. Talking about Bob Goff and talking about Barnard star. If you haven't looked at Barnard star through a telescope, you should. It's not going to look like anything, right? It's going to look like a plain old star, just a little bit brighter. Here, I'm going to stop sharing. It's just going to look like a plain old star, right? But in the northern hemisphere, it's the closest star that we can see, except the sun.
Uncle Bill got some more information about Wikipedia. If you can check on that, check the chat.
Proposed exoplanet. It was a proposed exoplanet. Alpha Centauri B. Okay. Well, that just got really complicated because, okay, so this is different than Proxima B. Okay. Wikipedia still lists Proxima Centauri B and Alpha Centauri B. Yeah. It's going to start getting messy here, folks. Okay. not to exist. So okay, but we definitely have a positive on Proxima, right? Proxima b for sure, and now we have a probably with Barnard star. So cool on them. You know, being able to measure meter per second radial velocity is an astonishing feat. It's really amazing. So anyway, yeah, take a look at Barnard star. It's pretty cool. It's the yeah, it's the fastest moving object that we see. Now that's just a relative motion thing, right? But it is moving faster across the sky than any other star. That's it. And we here, up here in the north, can see it. Yay! It's I want to say it's over around Ophiuchus, but I can't be sure about that. We should probably, tomorrow, let's take a look at Barnard star, because it's a pretty interesting little star, for sure, and maybe even more interesting now because it has a planet or two. So yeah, let's do that. Tomorrow. I usually don't plan this far ahead, but hey, I think that's a great topic for tomorrow. Maybe I'll even make some kind of preparation. I'll read things ahead of time. Who knows? All right, well, cool. I think for now I'm going to get out of here. I definitely have not had enough of this. So cheers. So if you haven't subscribed yet, make sure to do that, right? I mean, we talk astronomy here every single day, except occasionally, starting at 2 hours UTC. It's always starting at 2 hours UTC. And we sit around for an hour, think astronomy, talk astronomy, go off on some tangents. It's great. It's just casual, fun, get together with friends every single day. So make sure to subscribe if you haven't. Hit the thumbs up. I've noticed the last two live streams have had thumbs down. So I think the more the merrier. So yeah, just keep doing that.
That's what they say about people about dumbing down. If you ain't down with that, we got 2 words for you. Suck it.
Yeah, no, I'm doing this to share a passion, right? But it is nice to see that kind of reaction. So if you haven't yet, hit the thumbs up, hit the thumbs down, make some comments. I like to see those. If you want to be on the panel, right? I'm trying to fill this in, ding, 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 because then I don't have to talk as much, for sure. So, so if you want to be on the panel, right? Send me an email, cosmiclettuce@gmail.com, and just say I want to be on the panel, and then from that point until you tell me to stop, every single day. I will send you an email with the Hangouts link. And then you click on the link and you do, I'm not exactly sure what, and you pop in down here, right? And then, and I think that'll, that is definitely one of the improvements that I want to make to this live stream. Because
speaking of being on a panel and saying what I just said, Sunday local my time, I'm actually probably won't be here. I'm actually going to be doing another viewing party for another WWE pay-per-view.
Oh, far out. Well, I'm really glad that you have a lot of fun at those, because that is definitely what you should be doing, having the most fun that you possibly can. So yeah, we'll have a good time with that. So that'll be for us here in the United States, that would be Sunday, but UTC time, that would be Monday the 19th. Okay. All righty. Well, you heard it here first. All right. So take care, everybody. Have a great evening, a great day, and a great spin. One more spin. One more round, and we will be back here, right here. So take care. I will see you all later. Bye.
Later.